Hi, good day to everyone. Welcome back to our YouTube channel, where in this episode, we will be designing a low-rise concrete structure, typically a residential structure with hip roofing system. Definitely, we will be designing purlins, trusses, concrete columns, concrete beams, and foundation footing. This is our model drawn using AutoCAD software. Actually, I created this model for my tutorial in AutoCAD, for there are AutoCAD users requested me to model 3D trusses of hip roof using this software. And I have already recorded a video about this request. Now, to further save time, I would like to use this model again to create a video about designing the components of this structure, like purlins, trusses, columns, beams, and footing using staad software. Now, before getting to the seat design, we will model first this whole structure, including the truss, except for lens in staad structural design and modeling software. So, taking a look at our drawing, we have here 4 whole trusses as its main truss at the center, and this is the most common type of truss used in any structure with gable and hip roof system. We have also hip trusses, jack trusses, and creeper rafters. This is the detail of our whole truss. This is our hip truss and our roof framing plan. Now here in staad, click new, then write down the name of the project. Then browse for a folder where we save this project. I have created a folder here, which is hip roofing, and inside this folder is another folder. Then click create. Now to model the concrete frame, we would use this structure wizard command in the upper left side portion here. Then from the drop down menu, simply select frame models, and inside we just select bay frame. Double click and the parameters for bay frame would pop up. Now the length is 15 meters, number of bays 3, having equal distance. Height is 8.6 meters, including foundation. Number of bays along height 3, 2 meters for the foundation, 3.6 ground floor, 3 meters first floor. Width is 10 meters. Number of bays 2 with equal distance. Then click apply. Just exit this window, and herein just click yes to merge this into staad and would appear in the staad interface. If we want to reorient this structure just how it is oriented in AutoCAD to avoid confusion, we can rotate this by using staad rotate command. Here on how it is done, using beam cursor, highlight the model as shown here, then go to geometry in the ribbon toolbar and click rotate. The angle of rotation is 90 degrees. Now node 1 and node 2 are just points lying on the reference line, a line where the model has to rotate itself, a line where the model keeps the connection after rotation. Instead, the origin of this model must be in this corner. If we look at the staad global axis, which is right here, going to the right is positive x, going upward is positive y, and going in this direction is positive z. So the origin of this model must be indeed this corner. Now to check the actual origin of this model, just right click in the display screen, look for levels and click it. In the dialog box, look for show axis at origin and take the checkbox beside it. And the origin is in this location. So we have to move this origin to this point. To do this, right-click in a display screen and select Node Cursor. Double-click this point to pop up the coordinates of this point. Next, go to Geometry ribbon toolbar and click Move Node. Then select Move Origin. In the dialog box, copy the ordinates of the first box into this second box. Then click OK. That's it. Now take note, this line here is our workflow page control panel. During modeling, we start working from this left portion, starting from geometry, going to the right where the last part is design. Now we are currently working at geometry feeds, and we finish in this area, we now move on to the next page, which is property. If we click the property, a dialog box also pops up here, in which we see section and material. So this area here is about the property of components of the structure that we would be designing. Though we said a while ago that our workflow is from left going to the right, we are allowed to skip this property feeds for a while and instead go to material feeds to create first our concrete material. To proceed with, click this material, click concrete. Since we are creating concrete material, click the drop-down menu and select concrete. Then, write down here the material description or any name you want which is easy for you to remember. For me, I'll write F'(C) 3000. No space, then I would edit the Young's modulus value because 21 megapascal is my F'(C). So, the Young's modulus would be different. And then I would change this to 21,000 kilopascal. Then click OK. Now let's go back to property feeds and define the sections of columns, beams, and trusses. Our column dimension is 400 by 400 millimeter. Beam is 400 by 450 millimeter. And this is just an assumption. For top chord and bottom chord, we have double angle bar set back to back connected by 6 mm thick gusset plate. The web member is single angle bar with same property. Now let's define this. Click define, then click rectangle. Since our columns and beams are rectangular in shape, this is the profile of our rectangular beam. This JD here is actually the width of a beam, while YD is the depth of that beam. The vertical line is the y-axis and the horizontal line is x-axis. These two lines here. Our column is 0.4 by 0.4, and in our drop down is our material that we previously defined. Select this material, then click add. Next beam 0.4 by 0.5, click add. Next truss section. This is steel material, so we need to close this. And let's go to section database. Click this. Then click this tab for steel. Then click angle. Depending on what steel shape, ours is angle bar. Click LD. Then clear spacing is just the thickness of gusset plate, which is 0.006 meter. Then click view table. This tabulated data here is in inches. And our angle bar is 75 by 75 by 6 mm thick. So we just convert this into inches. So look for 3 by 3 by 0.25. Scroll down slowly here. So here is our section where the staad name is L3034. Now close this and look for 3034. And don't forget the material definition. Select A36 KSI. Then click add. So it is added here. Next, click this ST for single bar. Click add, then close. In case the material size is not available in that table, we can customize it using user table. Here, click user table, then click yes. Scroll down and select angle, then OK. Click add, give name here. Say for example, angle. Our D is this one. So right here 0.075, WF here 0.075, thickness of plants, this one here is 0.006 meter. Then to fill up this blank here, click calculate, and staad will calculate and fill this blank boxes up. Click OK, then close. Now to add that section here, click again user table, then angle. Highlight UPT angle, select material which is A36 KSI, then add and close. If you want to add another steel section for double angle, since we have already defined steel material here, we need to click user table manager in the specification ribbon toolbar to add another section. Then click new table, then select double angle in the drop down, then click add. Fill up only up to this area. Don't forget to give name here, let's say double angle. Then here, let's fill this up, 0.0075, 0.0075, 0.006, and 0.006 for the gasket plate. Then click calculate, then click OK. Then click close. To add that section here, click user table again, select material in the drop down, select 2 to pop up the double angle, highlight, then click add. So it is added here. That's it. Next, let's go to a specification page where in the dialog box we can find 3 important parts in a structural modeling: nodes, beams, and plates. In node, this is where we can model the rigid diaphragm of a structure. In plates, there are 6 specifications about plates. In beams, we have specification for compression, tension, inactive, fireproofing, imperfection, release, offset, property reduction factor, cable, and truss. In this tutorial, we would be using release, offset, and property reduction factor. Property reduction factor is about the moment of inertia of the members. In NSCP section 406.6.3.1.1, in the elastic analysis, the code allows us to use 70% of moment of inertia of columns and 35% for beams, as reflected in table 406.6.3.1.1a. So we would use this value in this table. Now to incorporate this value in staad, click property reduction factor. Reduction factor for cross-sectional area and torsion constant remains 1. For column, we have to write here 0.7 and 0.7, then click add. Again for beams, 0.35, 0.35, click add. Highlight this and apply this to column. Go to select in the ribbon toolbar, then geometry, nodes, and beams. Here in this beam, click the parallel drop down and select Y, since we are to select columns. Click it and all vertical members are selected in a wink of an eye. Assign to selected beams, assign. Next for beams, highlight again parallel X, click, parallel G, click, assign to selected beams, click assign. Next is offset. I have video about offset, how it has to be done, and what is this for. The height of truss is 1.4201 meters and the spacing of truss vertical web member is 1.25 meters with 8 base. Length from this support to other side is 10 meters. How it has 8 base? 1, 2, 3, 4, 5, 6, 7, 8. And we have 4 units of this whole truss here. We can find this in rope framing, which we would model next. Here, 1, 2, 3, 4. We have one truss in this span that lies on this column. So using node cursor, let us write down the ordinates of this node of this column. Double click the ordinates 0, 8.6, and 5. Close this. Now to start the truss modeling, let us go to Geometry and Structure Wizard. Click it. Select this whole truss by double clicking it. And then let us edit the value based on what we have in our drawing. Length is 10 meters with 8 base. Height is 1.4201. Width is 0. Then click apply. Close this dialog box. Then click yes. In this area, we'll write the node coordinates, remember a while ago? That is 0, 8.6, and 5. Click OK. Then just click OK. Next is the length of overhang. Let's measure this. That is 1.7 meters. To rotate this model, go to View ribbon toolbar, and in this area you can use all of this to adjust viewing, or we have shortcut in the keyboard. You can use left, right, up and down arrow depending on which angle you need to view the model. Now using the node cursor, highlight this node here. Go to Geometry, Translational Repeat. We are going to copy this node in this direction, which is negative x. By looking at the global axis, this is negative here. So default spacing is negative 1.7. And if you cannot see the node where it is on your keyboard, just press Shift plus key. Next, highlight the node again. Translational Repeat. Highlight Y. Spacing is negative 2. Click length steps to form a line downward, then click OK. Let us stretch this beam up to this beam. Highlight this beam, then get this beam number by hovering the mouse as shown here. Next, click stretch beam, then click to an existing member. Then look for that beam number. Then click apply. Now delete this beam. Next is, let us mirror this to other side. Highlight again this beam, go to Geometry, then click mirror here. Now in this dialog box, if we mirror this object to this area, this would be its plane mirror, which is here you have to choose which side is it standing. You can refer always to our global axis. In our case, our plane mirror is in YG. Click it, then click node on plane, which is this one. Then click OK. Now it's time to add properties to our truss. To better do this, let us isolate the sections with missing properties. Click Select in the ribbon toolbar, then click Attributes. Missing property drop down. Select missing property, then go to View in the ribbon toolbar. Here. Then click New View. Click Display the view in the active window. Then click OK. Select the double angle, then using beam cursor, select the top chord and bottom chord section like this. Then assign to selected beams, click assign. After that, highlight the single bar section for the web member. Then in the display screen, right click and in the selection mode, select drag line. This time, you can select now the web members as shown. Assign to selected beams, click assign. If we can remember, we have 4 units of this truss, spaced at 2.33 meters, so we need to copy 3 units of this. Now to do this, let us highlight the whole truss. And in geometry ribbon toolbar, click translational repeat. Now click G as its global direction, then positive 2.33 meters, 3 units. Notice here all is selected, meaning everything will be copied from this model, including the property assignment. Click OK, and then click display whole structure to show the whole structure. Now before we forget, in our drawing we have balcony here in this AutoCAD drawing. The distance is 2 meters. Now going back to staad model, highlight these beams here. Then in geometry, click translational repeat. Then click G as direction, 2 meters distance. Click length steps to have connection. Then click OK. To ensure every member has already its property assigned to avoid future warnings during analysis, just go to select attributes, missing property, and click missing property again. And here these 3 cantilever beams don't have properties yet. We will assign this 50 by 40, but before highlighting this, uncheck this area to remain this highlighted. Then select the section, then click assign. To view this model in rendered mode, just click the 3D rendering here. In this way, we can have closer look of our model. Or in shortcut command on our keyboard, just click Ctrl 4, then roll the wheel of our mouse forward and backward to zoom in and zoom out the rendered view. Simultaneously, use the left, right, up and downward arrow on our keyboard to rotate the rendered model for better view. We can press Ctrl 1 on our keyboard for 3D wireframe, Ctrl 2 for rendered view, and while in 3D wireframe or in rendered view, we can go back to a stick model by pressing Ctrl 0. So here, if our section like this, in the bottom chord of truss, the angle bar is not oriented correctly. It is currently facing downward. Look at it closely. Now in this case, we can reverse this orientation by rotating it to an angle of 180 degrees. And also the web member is not in correct orientation. The web member, if we look at it at the top view, it is positioned like this. And the angle with respect to the horizontal line is 45 degrees. Normally, it should be this way. So we need to rotate it by an angle of 45 degrees. Now to do this, beta angle comes in and plays this role. Beta angle is just about an angle rotation. Click beta angle, then here the default is 0. Change this to 180 degrees for bottom chord. Then again, 45 degrees for web member. Click OK. Now we have seen here two interests. Now to apply this to the sections mentioned, go back to section tab, click this column section to highlight the sections. Take note, this must be checked here. Go to select, then click inverse. Then in the display interface, right click and click new view. Click OK. Again, click beam section. Same procedure. After trusses have been completely isolated, go back to beta angle tab. Highlight this for bottom chord. Go to select in the ribbon toolbar, and in this area, click parallel to X for beams, because we have also parallel for plates and for geometry. So it must be here. Don't be confused. Click assign to selected beams, then assign. Next, highlight this for web member. Right click in the display area, and in the selection mode, select drag line. Then highlight all the web members like this. Click assign to selected beams, then click assign. Next, we are going to model this hip truss here. This hip truss here. Now in staad model, to start with that modeling, we are going to add beam to this portion. Go to geometry, then click add beam. Draw a beam here and also in the bottom. Now let us go to top view. This forms a triangle with another beam. Take note the spacing of web member is 1.25 meters. Now let us draw a triangle here. Now let us offset this line to this distance. This is in millimeter. So offset 1 to 50. Like that. So this is the spacing of web member in this diagonal line. So I am going to get the distance. I am going to project this point to this vertical line. So I will draw a line